Institute of Innovation and Industrial Management is an enabler of cooperations between industry and students. In innovation projects, the students are empowered to collaborate with industry partners, working on real-life challenges. Assisted by the staff of the Institute and backed by a generous budget to spend on their project, students run through all phases of an innovation process. In the new Schumpeter Laboratory for Innovation, lots of ideas are generated and tested by intensive prototyping. Digital production machines are used to come up with a fully functional prototype. After several iterations of the prototype, project results are presented to representatives from industry and university in a unique environment. The new lab offers state-of-the-art multimedia and communication systems. From a short 48 hours Makerthon to up to 7 months course of product innovation, you can choose the innovation project that fits best for you. Learn more about innovation, product development, and the maker movement in this extraordinary experience. Hi, my name is Vlad. Participating in an innovation project was one of the most challenging but also rewarding experiences of my lifetime. Get in touch now.
Good afternoon, everybody. Sorry about the sound, but you can hear me now. Good, right? Okay. Welcome, everybody, to this year's Innovation Gala. It will be a great event for our students. We have 5 student teams today, and they worked 8 months, roughly. I want to welcome also the company representatives, mainly in the first row, and our guests from all over. Let's start. So I have the clicker, or do you have? Sorry. Good. We have. I would like to show you something new. We call it Makerthon and SpInnovation. We will show you some new formats we tried out the last 2 years. And I think it's quite remarkable what students achieved in that formats. Afterwards, we switched to our keynote speaker, Johann Füller from University of Innsbruck. And then we have the 5 teams who present their results. This room here is the so-called Schumpeter Laboratory for Innovation at the Institute of Innovation and Industrial Management. My name is Christian Ramsauer. I'm the head of the institute, and I want to show you a little bit around about this laboratory. In this laboratory, we focus on exchange of ideas between industry, research, and also the so-called maker, mainly the students. So we want to bring together students, industry, and researchers in that format, in that rooms here, because we want to make sure that we create new ideas, and not just ideas in the head, but to make sure that we have physical prototypes, also digital prototypes. The physical prototype is done in our workshop at the end of this hall. The digital prototype is something new also for us as mechanical engineers, I have to say, and we focused a lot on that the last few years. Yeah, well, we have multimedia and communication systems, as you can see. We use some of that, but we can use a lot if you want to do video conferencing or include outside people. It's very a modern facility. I want to show you some example about product innovation. Then Andreas Kohlweiss will give you an overview about the format Makerthon, and Patrick Herstetter will talk about SpInnovation. We had the day before yesterday a very successful end of that course, and I think we will have some new startups soon from student-founded companies. I'm sure. Product innovation. This is the backbone of our innovation initiative. That started 2006 and 2007 with 11 students, 1 project, and a company partner from Philips. And it all started with Mario Fallast, who is here with us, because he was a student assistant at the Institute from Josef Wohins. We celebrated his 80th birthday this morning. And Mario was exchange student. He went to Aalto in Finland, Helsinki, and came back with that idea. And Josef Wohins said, let's try it out. And out of that, a series of product innovation projects started, beginning with 1 company partner, then another 1 company partner and 2 company partners. Philips was always part of that, with roughly 10,000 euros, I think, or 8,000 euros. And then I started in 2011. I thought, like, we have to double or triple the income. And then we had new companies like Fronius, Magna, voestalpine, and Asturia, Porsche Austria, Infineon, and other Austrian companies. So today we have 25 students in these 5 teams, with these 5 company partners, Andritz, AVL, Fronius, Palfinger, and TDK. In total, 500 students passed this format, 74 project teams, and 36 company partners over all these years. I have to say that's quite remarkable. First project, just give you a little overview. That was a project that made it to German TV shows and to what's the name of Austrian TV at 7 p.m. Steiermark heute, right? So the idea was, how can you make water in the desert? Quite interesting task, and the students, led by Mario, came up with a great solution. That was the starting point. 2014, as an example, Fronius project. Klaus Fronius came to us and said, well, I have an idea, but my R&D department back home has no capacity to cope my ideas, so how about Christian Ramsauer, could you help me? And out of that, that's Mr. Schiffbanker, he's now at AVL. He was the project manager, and he developed a product where you can harvest energy out of an apartment. If you're a homeowner, you can put something on your roof, photovoltaic or something else, windmill or something. But when you are in an apartment of a 40-story high-rise, how can you harvest in an apartment, in a condo? And they came up with a great product. And out of that, also a startup started a few years ago. It's a company called EET. And Klaus Fronius is very proud of that. He is a main investor in that company. And I think 2 years ago or 3 years ago, they won the Huschka Prize in Vienna. It was really a great success also for Klaus Fronius and also for us. 2015 and 16, Magna provided us with a task called development of new ideas for the power transmission between 2 shafts in 4-wheel drive system. So I said to the head of R&D, you know, bunch of students focus on something what the automotive industry has already done for many years. I think you give me the money, but I don't think that you will get lots of ideas. But I was wrong. The students came up with many ideas, and Magna Powertrain was very happy with that ideas, and they used it for different things. Andritz, also a major company with the task optimize tissue machines in terms of costs, quality, and functionality by using value analysis, a course we offer our students. Remarkable outcome using ultrasonic drying instead of conventional methods, something what is quite interesting today with the energy prices raising up. That was a few years ago, and Andritz was very happy with that. Last but not least, a company called Paya in St. Bartholomew. Students developed an all-in-one product for close shave, stubble beards, and styling. I was asking for men or for women. No, it's for everybody. And they came up with something new. And they were a great company, great student team. And today we have new students, new teams. These are some impressions of the last few weeks, the last few months. And you will hear soon what they came up with in their presentations. Let me focus now on this quite new format called Makerthon, and I would like to ask Andreas to come on stage and give his speech.
Thank you for the introduction. So, thank you for the introduction. So first of all, what is a Makerthon? As you can read, Makerthon means the combination of maker and marathon. Basically, student teams work on real-life industry challenges in the context of open innovation to develop a prototype. So in general, we mostly have 2 industry challenges from our industry partners. The students get guided by the industry experts and by experts of the institute through the Makerthon to develop a promising solution concept. What we are using to guide the students a bit better is an adapted design thinking approach. What you can see here is from the fitter better in the needs of our 48 hours, we are starting with understanding the challenge, which means students have enough time to interview the industry experts. What is the challenge actually about? They can use techniques like customer journey mapping or similar things. In detecting the real problem, students dig deeper. That means to build a comprehensive understanding for the real problem of the challenge. And also to search for some first rough solutions, maybe also in different industry fields. Idea generation, of course, means to generate a lot of ideas. Basically, go for quantity, use techniques like brainstorming, brainwriting, and all methods like this. In the idea selection phase, the students again get very intense feedback of the industry partners, and together with them, they maybe try to do it with a morphological box, but they decide for the most promising solution concept. For the prototyping stage, of course, they can use the comprehensive prototyping machinery which we have in our Fab Lab. Usually this takes place in the last 1.5 days. Last but not least, the event concludes with the presentation of the results, which means basically that every team has to present the solution, the concept, to the audience consisting of all of the industry experts, the students, and the academic staff. For today, I have some highlights with me. The first one is the Makerthon out of the winter term 2018-2019. Logic Data was looking for a cost-effective electromechanical mechanism for the adjustable bed systems. What you can see on the left picture is a concept which is called the Grandler frame, and this is basically the combination of very easy geometry shapes in combination with linear movement to adjust the bed frame. On the right side, you see the 3-step nap. What they did, they used a rope combined with a special arrangement of the joints to adjust the bed frame. The next project, I think our industry partner is here, Mario. Yeah, hi Mario. Was basically to automate the process of placing those stabilizer beds under the stabilizer legs. So you have to do this to increase the surface below these legs. And so the students developed in a concept which was called PAL-FLAP, an automated version of it, by using just the geometry basically to position the stabilizer bed automatically. This last project which I'm presenting today was basically out of the last winter term. So here our industry partner Michael is also here. And basically there it was the task to redevelop, to optimize heavy duty and truck fuel measurement, fuel consumption measurement system of AVL. What makes this concept special? So it's called FabStack, and the team was using innovative materials, innovative manufacturing techniques, combined with a special arrangement of the components to bring the mass in the center of the gravity and to optimize so the product in terms of its structure and also in the possibility to mount it on a truck. Well, if you're interested to feel the Makerthon spirit, then get in contact with me after the official part of this event. So we are planning the next Makerthon for November, and we are already looking for industry partners as well as for motivated students. Thank you.
Okay. Look into that faces of that people after 48 hours of heavy work. They get tons of food from us. They don't need to leave the room except sleeping, but at the final presentation, when they are very tired, they were very happy, and that's the spirit of this innovation. Good, the next format is SpInnovation. This is really very new, and I'm very happy what we achieved 2 days ago, and Patrick will show you more.
Thank you, Christian. So, warm welcome from my side. Thank you very much, Christian, for the introduction. I'm here today to show you SpInnovation. And SpInnovation is a completely new course for us, so it's quite young and was in development. We only had 2 batches so far officially. But before I dig into SpInnovation, I want to deal with a number, 610. That is actually the number of invention disclosures we had at Graz University of Technology throughout the last decade. And already a third of those are actually patented. And patents can go different ways. You can have a successful implementation within a short amount of time. You can have a dismissal after a few years. But most of the times, a patent waits for its chance and waits for its opportunity to be used in the field. So that's where SpInnovation now comes in, because it's a format that we developed together with the Research and Technology House here at TU Graz. And it's a 7-week course with small student teams, and they take that patent out of the shelf and give it the attention that it deserves. We support them, obviously, with our facilities, but it's more than just a classroom project. In this project, which combines entrepreneurship and patents, we basically give them expertise by inventors, by startup experts, by entrepreneurs, and all information they additionally need. They go through a very comprehensive process throughout the way. So we have a patent analysis and target market screening where the students have a look at where can we use this patent, where was it intended to be used, is the market viable at all. Afterwards, they go to idea generation and evaluation, so they need to generate a high number of ideas, look where the patent still could be applied apart from the obvious, and also evaluate those ideas. Afterwards, if necessary, they conduct some prototyping, but mainly we are focusing on sketching the business opportunity, because in the end, they will present the results internally. And after they do that, they have to make a decision whether or not to continue with this patent because they think they have a meaningful idea for application. And if they decide to continue, we are happy to support them with contacts and with help for further accelerator programs. This batch, I already told you, it was the second one we conducted. We had 2 patents and 2 teams. One was dealing with multisensitive smart skin, and the other with metal recovery from waste. Unfortunately, due to time constraints, the team members could not present it on their own today because it was on a very short notice. So I will just give you a quick overview over one of the patents. It's the multisensitive smart skin, and what it does essentially is it's an electronic skin made of biocompatible materials with a high precision in measurement and measuring 3 inputs at the same time, simultaneously temperature, humidity, and also force. The team thought of 3 usage fields and application fields, which is namely the targeted drug delivery or wound healing, because the measurements are so precise that you could measure small changes in temperature and you could deliver the drugs exactly where they are needed, for example, when you have an inflammation. Smart Skin in prosthetics. The high precision will give you free stimuli for feedback and enable the user to have a more natural, intuitive control. And the third one was a vertical sensor patch for competitive sailing. Because in competitive sailing, it's extremely important to know where the wind comes from and at which force it comes. So that were the three fields that they looked into. And what I'm really happy about is that this time both teams decided to look further into the idea, and maybe we see a startup or a spin-off in a few months. Let's see. Thank you.
Thank you, Patrick. We continue with our keynote speaker, Johann Füller. And I would like to talk a little bit about him before he comes on stage. Johann Füller has been a professor and at the chair of Innovation and Entrepreneurship at the Department of Strategic Management, Marketing and Tourism at the University of Innsbruck since 2012. He is a fellow at the NASA Tournament Lab Research at Harvard University. He received his doctorate in marketing on the topic of community-based innovations, virtual integration of online consumer groups into new product development. His doctor fathers are Professor Hans Mühlbacher from Innsbruck and Professor Eric von Hippel from the MIT. That's the connection where we got to know each other, by the way, a long time ago. The graduated mechanical engineer and industrial engineer completed his career with a master in international business. Study visits took him to US, France, and Spain. Prior to his scientific career, Johann Füller worked for 3 years as a management consultant at PricewaterhouseCoopers in the area of strategic change. But he is also an entrepreneur. He founded the company called Hyve in Munich. He has been a CEO until recently. And the company is a well-recognized Munich-based innovation agency advising international companies on the development of customer-centric innovations. A few days or a few weeks ago, he sold his company after 20-something years. Congratulations. Johann Füller's researches innovative customer behavior in online communities, as well as the use of online communities for product development. The research focuses on open and user innovation. Current research is directed towards the study of the crowd as a source of innovation and digital transformation. Johann published in journals such as California Management Review, Harvard Business Manager, Industrial Marketing Management, and Journal of Product Innovation Management, and many others. Johann, please come on stage, and I'm looking forward to your presentation.
Thank you very much, and congratulations for this special and fantastic event, and also this kind of chair of innovation and industrial management. I'm really thrilled and happy being here. It's extraordinary. And the thing I want to give you some insights in today is really fascinating, because we are all innovators. We all want to come up with successful new solutions. And the way how we do that changed dramatically within the last 20 years. When I started with my PhD, it was still, we invent and develop the products in-house. Once of a sudden we said, it may make sense to integrate the customers, and we have to become more centric, and we have to think about it. Nowadays it's, we innovate in ecosystem. Everything is changing so fast, so we want to collaborate with universities, with startups, etc. We want to develop products together with the crowd. And now we are again really going to the next paradigm shift. How can we apply AI in order to automatize innovation, or at least to get some assistance and to support the innovation process? And later, since ChatGPT, we all are convinced, this AI can write articles, they can write papers, they can generate ideas. So how the hell can we use it and apply it for innovation management? And that's the kind of topic I want to discuss with you today and give you a couple of examples on that. So first of all, what do I mean by AI? Yes, it's this technology stack which may support, which may substitute, or which may assist you to do innovation management better. And I've seen the fantastic presentations about the double diamond and the innovation management process, etc., about the IP tracking. So, of course, there are a lot of, let's say, time-consuming activities, and how can we apply AI? Let me give you an example, but first, why is this all possible nowadays? Because, yes, we do have the internet and we have all the information regarding complaints, regarding ideas, regarding patents, regarding startups. Everything is, and all the research, the fantastic papers, we find them on the internet. So if we would know all the stuff which is already there, probably we could do our job better. And now we have the computational power exactly to analyze all this data more or less in real time and in kind of forms which haven't been existing a couple of years ago. So it's not, we could argue, is it AI or is it human intelligence? Someone can just, let's say, access all this kind of knowledge and information and can create sense out of it. That's so fantastic, but of course it comes also with some downsides and some problems, and we have to deal and think about it. So, going back to the innovation management, of course, we want to come up with the best solutions. And in order to come up with the best solutions, we have those heuristics and approaches. We have heard about them. First of all, we really want to understand the problem. Einstein already said, if I really have about 60 minutes of time to solve one of the world dramatic problems, I would spend about 50 minutes to understand the problem. So how can we understand the problem, and then how can we generate the solutions? And most of the time it's kind of a convergent and divergent thinking. So first of all, we try to understand, we generate a lot of understanding, and then we decide what kind of problems we really want to follow up. Again, we generate a lot of ideas and then probably select those ones which are most promising. And the information is already there. Let's give you some examples. For example, for Nivea, they are body skincare experts. So they wanted to know what are the need gaps, what are the kind of problems consumers are facing. And of course, people are talking a lot about this topic. You find 1.7 million posts, but no one will read all those posts because most of them are really scrappy, to be honest. But if you have a machine, and if you train the machine, for example, we coded 5,000 of those posts manually, and then we just learned the machine to decide, okay, what are kind of relevant problems or not. And it allowed us to really scan and analyze all this kind of data. Or another, let's say, field of application. You do not only want to know what kind of problems do exist, probably you want to know who has the problem. Is it an ordinary user, or is it someone who is really thinking ahead, a so-called lead user, and those guys are really driving, let's say, the markets. So, and nowadays you find not only a lot of information regarding people talking about problems, of course you have the footprint of the people talking about. You have LinkedIn and all this kind of other, let's say, social media platforms, so you can really also detect, okay, who are those guys? Another field is, and I'll give you an example in more detail, in innovation management, it's very important to know what's trend and what's not that trendy. And for example, you can analyze crowdsourcing platforms like Kickstarter to analyze what are the projects which got funded and may be ahead of the market. You generate a lot of ideas. Sometimes you have the burden to select the right idea. For example, if you apply a crowdsourcing, you may get, in this case for Mondelez, you may get 551 ideas for chocolate, only chocolate bars. But of course, Mondelez cannot produce all the 551 ideas. So which one is the really winning concept? And you can apply, for example, this kind of topic modeling in order to identify some ingredients which may, let's say, contribute to a more or less promising idea you can select on. So how does this work? A bit in more detail. For example, who knows Kickstarter? Who invested in Kickstarter? some of you, what you do in Kickstarter, everyone, you can present your cool ideas, but probably the company is already, let's say, buying them, but you can present them and you can ask for funding. And you find all those projects which asked for fundings, and those have been projects which have been tremendously successful. And this kind of Pebble Watch, yes, it looks similar to the Apple Watch nowadays, but the thing is, it was years before the Apple Watch, so 5 years before. So if we know all the projects we are there and we can mine them and see what are the successful products compared to the less successful products, probably we have a good understanding what may become trendy and what may become a future market or not, early in advance. And why is this possible? Because you have data. You have hard data, you have the funding goal over there, and, oops, you have the funding goal here, oops, and you have the description of the project. And you can semantically analyze all the text data, and then you can identify patterns or characteristics which make and contribute to the success. How does this work? I give you an example. Now let's apply human AI. On the left-hand side, you see helmets which have got successful funding. On the right-hand side, they failed their funding. What's the difference between the left ones and the right ones? Light? What else? Light, again, style, yes, style, light, style, and maybe safety. So the helmets on the left-hand side, they look stylish, they have a nice design, they deal with safety, and they have this kind of light things. Those on the right-hand side, they are too futuristic, they have head-mounted displays, etc., navigation systems, etc. And this is human AI, so we could analyze and say, okay, if we are a bicycle helmet company, we have to work and invest in lightning, stylish helmets and design. Safety. And that's exactly what you can do by applying text mining. What you do, you actually divide all the text which is written into subtopics, and you can see, for example, those are the topics regarding the helmets. And then you can create some vectors and you can do an analysis and you see what kind of topics contribute to the successful funding compared to what topics do not contribute. And it's not just a single topic, it's the combination and the bundles and the triples and the quadruples of those kind of topics. So you really can analyze content automatically without having fixed data, because you just create this kind of data. And that's what we did, for example. So you can see, you analyze, and the future, or the fantastic thing about computational skills, it's almost abundant. All the projects on Kickstarter at that time, we analyzed. So you see, for example, what are the product categories? You see, for example, smart security, smart lighting, smart room climate gadgets. You see the number of projects, how much funding they get, how much successful and how much less successful projects you got. And so you do the same thing like with the helmets. You compare those successful ones with the less successful ones, and you can come up with some insights. And at least you as a company, you may decide, okay, should I go into pet butler gadgets or projects or not? Before I did not even know what it meant, but I can give you some more insights if you're interested in. But nowadays it's generative design. It's prompt engineering. For example, there is a generative AI, it's called DALL-E 2, it's also from OpenAI. You can give a prompt, a bowl of soup as a planet, and this AI generates this picture. But you can say, okay, I developed a couch and I just want to have the scenery, for example, a Bauhaus style. So you just, let's say, integrate your couch into this automatic or artificially generated scenery. Or you can come up with one design and then the AI is generating different versions of the design. You know this guy? You can enter, for example, this kind of, you call it prompt, this guy is floating in space, he wears a white spacesuit with the NASA logo and matching space helmet, etc. That's what you get. You can, for example, of course, manipulate it, but somehow if you think about, okay, this may be this guy. And of course, you can combine it and can make it much more complex, and I want to give you some insights regarding deep fakes. So there is a site, you see Tom Cruise, and all those kind of Tom Cruise videos are just artificially generated. Some sound should be there.
above my head. Like Jesus said, I'm gonna dance, dance, dance with my hands, hands above my head. Like Jesus.
And of course, it's just fun, but all of it is artificially generated. And of course, it also shows you the danger we have to deal with. But the thing is about nowadays, every one of you is talking about robotics and bots. Nowadays, we are talking about digital humans. And imagine you can even say, oh, this kind of service encounter, it's the guy you like the most, or it's this kind of superstar, and he can individualize the kind of messages you want to hear or not. It's not, we are not there yet. The technology, where it comes from, I just give you some insights right now. It comes, of course, from the film industry. There should be again some...
The people running this device are going to use 25 cameras and more than 15,000 lights to capture a facial scan that can then be used to create a digital avatar of me. This light stage is perhaps the most advanced device there is for creating these high-resolution facial scans. It took hundreds of pictures of me, making a series of strange faces in a variety of light settings. The data captured is so detailed that an artist can use a computer to replicate what my face would look like in any place, at any time, making any expression.
Hi there, I'm Sam.
Companies like Soul Machines are using digital human technology to create virtual assistants which are powered by AI, kind of like living chatbots.
So what is your purpose?
Get ready because I'm the future of human-machine cooperation. I'm built to think and feel with technology modeled on neuroscience.
A Hollywood visual effects artist co-founded this tech company, which uses digital representatives to perform tasks like selling skincare products and collecting debts. Meanwhile, the Pinscreen app wants you to use digital humans to buy clothes. Users can create photorealistic 3D avatars from a single image and then see how an outfit looks before buying. The creator of this free app believes that soon all humans will have at least one digital avatar. And then there are creators who are slipping into anime-style digital skins to interact with people online.
I'm going to be a virtual YouTuber.
YouTube sensation and violinist Lindsey Sterling recently performed in virtual reality, appearing before tens of thousands of people using her stylized digital avatar. As avatars become both easier to make and more lifelike, digital forgeries like deepfakes and other fabricated videos, such as this doctored clip of Mark Zuckerberg on Instagram, could pose a real threat.
So it's really fascinating on the one hand side, and on the other hand, of course, it's really, really dangerous. But the reality is that the technology and all the skills are more or less there, and that we are just on another, let's say, a change that, for example, all those chatbots not just have a, let's say, a verbal interface, but you may interact with humans soon. And we do another project here. Of course, if machines become more and more intelligent, maybe they should also become more emotionally intelligent. And how can you make machines empathic? There is a startup, and what they do, for example, with computer vision, they measure the facial expressions on the one hand side, and due to the color changes on your forehead, you can also measure the heart rate variability. And by having the heart rate variability, the change of the heart rate, which is as precise as my Garmin here, you can measure arousal on the one hand side, and by the facial expressions you can measure the valence, which is good or bad. So you have a two-dimensional grid, and this allows you to really recognize the emotional state, for example. You have an eye tracking here. You can come up with all the kind of different information regarding what do you get from your interaction partner. Is he in the flow? Is he stressed? Is he emotionally attached? What is changing here? And now we did one experiment of this kind of digital avatars, and of course you have technology that this avatar is exactly saying what you want to hear, etc. And based on the reaction of the guy she is talking to, she may have an individualized message which is taking place here.
Technology helps me to recognize and react to the emotional expressions of customers. Now, let me try to cheer you up and tell you some funny jokes. What happens when you cross a cell phone with a skunk? You get stinky service. I saw you laughing. For happy customers, we offer some special deals, like getting 50% off on an Apple Watch. It was nice to meet you.
So this is just some of the experiments we are doing, fully artificially generated bots with the information, and we have some probants in the, let's say, experimental condition and see how they react, and depending on the reactions, we give them different informations. And seeing how, for example, you can find special moments, etc., and how to deal with the different service encounters depending if someone is loving or someone is really frustrated. Of course, you have to provide a different dialogue then. One thing in the innovation management, we use this technology. For example, we present ideas. You will pitch your ideas today, and then by observing the crowd, the observers, we can predict if this is a successful or a less successful idea without asking, just by having the interaction between the arousal and the valence. For example, this allows us to reduce the burden of idea evaluation by just watching the guys when they are watching, for example, the pitches. But of course, I mentioned that not all of it is, let's say, already regulated. We once did a project with Facebook, and we wanted to know if the AI Act from the European Union is applicable. And we did this project with 50 experts, and the output was, it's not applicable, it's not even understandable for the experts. So how the hell should you deal with this kind of Jobs Act? There is a lot of additional research. We all have to think about it, not just from a technological perspective, but also from an ethical and also from a social perspective in order to really deal with it. And I think we have a great chance here in doing. But I just looking on the watch, I have 2 more minutes, and then I have maybe 2 more minutes extra. The thing is, how Christian is laughing, so everything is okay so far. The thing is, how can we use this stuff? And we did some, let's say, interviews and a survey with practitioners, with innovation managers. And what they see is that this kind of technology stack will really change how the way we innovate. And they see, for example, a 59% increase in individual fit, or that you increase the speed, or you can come up with a much better decision making if you are more informed. They don't see that much that we reduce the costs by applying those technologies, but on the other hand, there are some huge benefits, and it's most for kind of analytical tasks, to mine and analyze, identify trends, to individualize your marketing, to scout technology, to do some concept testing. But this is a kind of a 2-year-old study, because what is the hottest right now is really generate ideas. And I can show you, and then I jump over there. There are different, let's say, groups of companies. Some, they really see a huge potential and they want to become front runners. They invest more, they provide a better education, they interact more, they really take it into the core. Some are, oh, we use it on an occasional base, and some others may say, oh, it's really not needed for us, it's a nice gadget, it will go away. We have seen many things here. I jump over this one. That's, for example, one thing all of your companies should experiment before they do the decision. Just use ChatGPT, and what we did here, an idea contest. We said, brainstorm some ideas rethinking household towels. It was for a real company, and we did a crowdsourcing project in parallel because we wanted to find out if the crowd or ChatGPT is doing better ideas. And to be honest, most of the ideas are of a kind of a equal level. And then you can go into more detail. You can say, okay, elaborate this idea on food and cooking in more detail, and you can, of course, train and engineer all those kind of prompts in order to get 10 ideas, 100 ideas. You can ask, you can get as many ideas as you want. Another project is, and we all know from innovation management, that sometimes we have a non-novelty bias. That means if an idea is very new, very often in the company, it's very hard to select this one, and 5 years later we say, oh, we should have done this one. That was a really good one. And for example, what you can do by having all this data, if you have the ideas, you can rate the novelty and the uniqueness of the idea. And those ideas with a very high novelty or uniqueness, for example, you may have an additional view on them because you know, okay, we are biased towards, usually we go for the average ideas. Another thing we are doing here, summarization. No one wants to read all the text. And can ideas, for example, which usually are more than 1 page, can they be summarized in 1 and 2 and 3 sentences? Of course they can. But how much information you lose? Is it better to have a 1-sentence summary, a 2-sentence summary? What we found out, for example, if you have a 2-sentence summary, you don't miss any of the most promising ideas. So you really can reduce, for example, the time which we stopped for reading 300 ideas, which usually takes about 99 seconds per idea. You can reduce it, for example, to 18 seconds and without losing any information. And those are some kind of easy fields of applications. I go over there. So probably before you decide what you can do with AI in innovation management, you have to think about, okay, do you really see any potential in it? What could be the strategic benefit of it? Then what kind of know-how is needed? Do you have the know-how? Which university could have the know-how? Which kind of startup, etc.? How would you want to build it up? And also, of course, nowadays, as time and all those technologies are changing that fast, probably also it would be a wise idea to partner and to look for someone who can help you in doing this. So that was it in a quick, let's say, run, an overview regarding innovation management in times of AI. Thanks.
Thank you, Johann. I'm sure some of you might have questions, so he will stay for a few minutes if you have questions to that very interesting topic, which is on our mind these days. Artificial intelligence. Horst.
Yeah, so thanks for this really nice talk. And the last point you mentioned, thanks. So thanks for this nice talk. So one of the last points you mentioned is we're sort of looking for novel, innovative ideas that are very rare. Now we know that sort of this ChatGPT and this type of things also means basically, you know, common things. They go for statistics, what appear more often. You know, if let's think about the future. If we just rely on sort of idea generation using this type of tools, we might sort of simply, you know, all over certain go down and not find the real interesting things anymore. How do you think about that?
Absolutely. I think that way that we could create this kind of innovation bubble, like the kind of social media bubble we all know nowadays, that you all get this boring stuff just because you looked it up once and you get it again and again. So the good thing is that we as humans, I guess we are still dominating, and I didn't tell you, it's just an assistance right now, and it's not yet taking over AI. And one of the problems we really have to deal with is, okay, how can we identify the really new things not already on the landscape of AI, for example?
If you allow me, another quick thought. So if, you know, people are lazy, well, a lot of people are lazy. And if they have now these fantastic tools, how do we prevent them, you know, for, as you said, using them as assistants is just perfect. You know, get a brainstorming and then think further of that. You know, but you know, what prevents them for just getting? I can give my presentation, have my 10 minutes, and that's it. My boss is happy and it looks nice. Everything is nice. How do we prevent this sort of laziness of people?
It's a good question. We also have those smart students in Innsbruck, for example. They do their homework and their paper reviews by using ChatGPT. On the one hand side, probably this is smart, and they are using the tools like we used Google for searching, or we use some scientific calculators. But on the other hand, they abuse it and they become lazier and lazier. I don't have a kind of general answer to your very good question. I guess we all have to think about, on the one hand side, working on formats and programs where we want to, let's say, have the pure human AI or human eye intelligence. And on the other hand, we want to come up with teams where we should get the best results, and we don't care if it's human or AI based. By the way, it's still a philosophical question, because all this information and what can be thought probably is reproduced by the AI, but what is above the things any human thought about it? So this is, on a philosophical way, it would be also a very nice debate, but you're absolutely true that, for example, probably the typical KPIs in organizations, oh, that was a nice summary, and now he gets promotion. Probably that's not the best way, because AI should get the promotion. Yeah, those are challenges we have to deal with it. I don't have a good answer for that yet, but we have to address it.
Other questions? Roland Winkler.
Thanks a lot. I mean, you have nicely shown what's already possible with AI and how it can already provide value add in the innovation process. And now, assuming this exponential growth of performance, intelligence, gains, and so on, what's your future scenario in 5 years from now?
I think we have a tremendous increase of performance, and it will become harder and harder, and in some fields, probably in kind of adjustments, in individualizations, probably the AI may become better also in innovation than in other fields. We know it, for example, in financial trading, etc. There are all those bots working for Goldman Sachs and some other companies, and I'm quite sure that we already reached the tipping point. And as you probably also assume, it's not the question it works or it doesn't work, it's just a matter how the performance may increase, that it really becomes at the same level or it becomes applicable. So my guess, it will be faster than we now think of. Maybe in 2 years, technologies would be there. The good thing nowadays, it's not just, oh, probably people don't have enough work anymore, because nowadays we're facing the problem that we have more problems and we have more work and not enough, let's say, employees. So probably it's the only way in order to solve some, let's say, constraints regarding having enough power.
There was another question over there, right, this gentleman?
Yeah. Hi. You used the analysis of Kickstarter successes as one of your examples. And I don't know how far you got into that, but how much is this a danger that there are quite a number of known Kickstarter campaigns that were financially very successful, but as a project itself failed along the way later, or were from the start on basically scams? So how much is that? Does that influence the analysis?
I mean, having a good idea or having a prototype which attracts a lot of attention does not mean that at the end you have a financially viable company and even not a product because there are so many steps in between. You're absolutely right. And some are even, let's say, biased by doing some additional funding because they just want to have the exposure and they do it for marketing reasons and not really to attract enough fundings. This is like welcome to the real world, and we have to deal with all this kind of biases and offsets, etc. So it's really interesting from a researcher perspective. It's fantastic, you know. There are so many unsolved problems yet or answers, and this is why I really would like to encourage all the younger, let's say, students or PhDs that this is fantastic for us also to look how this technology may change and transform the way we work. And the one thing is, I'm absolutely convinced that it will tremendously change everything like electricity or like computers or like the internet. This is a really general purpose technology which is changing things dramatically.
Maybe one or two more questions, gentlemen in the first row.
AI is depending very much on the input data. So the question is between the US, Europe and China. You know, the mindset of US with America first. Then you have the data protection rules in Europe, and you have the input data from China, I would say, you know, already changed in certain ways. So of whom do you think they get the best AI out of it, and what will be the result?
I mean, probably you can answer the question also yourself. I mean, we, on a technological perspective or training the AI or the algorithms, of course, we have a huge disadvantage because we have to respect all this kind of data protection rules and rights, etc., which on the one hand side are a good thing for our society because we want to live in this kind of free and democratic one. On the other hand, probably we lose again big times, and all this kind of big investments probably are done in the US and probably even bigger ones in China where we don't know what's going on. Yes, those are problems. Those are tough problems. And probably only if we collaborate together, if we find the use cases, if we also probably we have to have some legislation on the one hand side, but we also need some big investments and also courage and brave guys like I learned today. Today in this kind of university there are a lot of brave guys who probably have to think about exactly those topics.
Last question, if we have one.
I mean, so far, I guess it's still easy because at the end it's humans who decide, but life isn't fair, and probably, as you mentioned, or the guy who was asking mentioned that we aren't in a world where everything is fine and then there is the, let's say, bad and dangerous AI. We are living in worlds where the democratic systems become less and less successful, and we have more autocratic, let's say, approaches, not only in the policy making, but also in the business field. So this is something which really is embarrassing me, that of course the people's fantasies and the technology is agnostic. It's not good or bad. It's just the technology. It always is what we are, let's say, using and applying the technology. And one thing for sure, that also the evil guys may try to make sense. And on the other hand, again, we have huge opportunities. I always say, if you're an innovator, you never get unemployment because we have so many unsolved problems with AI, without AI. And so there's a lot to do to work on that and to find ways how we deal with those issues.
Okay, thank you very much, Johann. Danke. Johann, you left the stage too early. I have some little present for you. Thank you very much.
Okay, thanks.
Okay, now it's time for our student teams, and I would like to introduce to you Marion Unek, who is the project manager of all student teams.
Thank you. Thank you, Professor Ramsauer, and also a warm welcome from me to you here live in the Schumpeter Laboratory for Innovation and also at home or worldwide with our live stream. Hello. Well, it was already impressive what we got to see today. You get insights into the Makerthon and SpInnovation from my two colleagues, Andreas Kohlweis and Patrick Herstetter, and we got this amazing keynote speech from Professor Johann Füller. Also, thank you from my side. But as the PI project leader, I now want to spin the focus back to the history we saw at the beginning of this presentation and see the future or the actual projects of this year. And it's always an incredible, wonderful, and sometimes exhausting journey to get with those teams to this point. And in this year, we had 25 students participating in 5 student teams with our company partners, Andritz, AVL, Fronius, Palfinger, and TDK. But product innovation, you think it's simple, but it actually goes deeper than this, because the key word of innovation or of this product innovation project is growth. And not only growing in terms of skills, but also growing as a person and learning to overcome obstacles, learning to resolve conflicts with people from different cultures and nationalities, because as you all know, we are interdisciplinary, which means we have students from all various student fields, and also not just growing, but also making new friends. And therefore, as the PI project leader, I want to say that I'm very proud of each and every single student and of each and every single team. They not only grow out of themselves and got engaged and invested a lot of time, because it's not that they get like money for it or a lot of ECTS for it. It's their free time and their engagement that their students are here today. So thank you, students, and also thank you for helping me grow, becoming a better project leader, and becoming a better teacher. But now, let me... Thank you. Now, ladies and gentlemen, let us bring the focus to our teams. And our first student team today is talking about paper. It comes in all shapes and in all sizes, and every one of us uses it daily. But have you ever stopped and think about how paper, or more accurately pulp, the precursor of paper, is produced? Well, our first student team looked at the modern pulp mills and recovering energy in water, from dryer exhaust to improve sustainability. So welcome on stage the A team and Sebastian and Clemens.
Hi. Oh, sorry. Good afternoon, ladies and gentlemen, and welcome to our final presentation of the A team. Today is all about sustainable pulp production.
But Sebastian, what does shirts, yogurt and electronics have to do with sustainable pulp production?
Well, all of these 3 items can contain pulp fibers. And did you know that pulp is also the basis for paper production? Our company partner Andritz is the market leader in the pulp and paper industry. Our challenge, increasing energy efficiency. What you can see here is that these pulp mills are usually very large. And these pulp mills are usually very energy self-sufficient, with around 400 similar ones worldwide. Just one of them produces enough pulp to fill up to 500 trucks per day. What you can see here is now a perfect example of a typical pulp mill. There are a lot of different plants combined, but for us, it all boils down to this. The 2 main sources for pulp production are wood and water. there are many additional processes going on, such as chipping, cooking, bleaching, and so on, until we finally get to the pulp drying section. The heart of the pulp drying process is the dryer, which is the size of the building you are sitting in right now. This huge amount of pulp production also requires a lot of energy. So rather than becoming an issue, it is a great opportunity. But why do we dry the pulp at all? Well, first, pulp contains a lot of water, and therefore shipping it beforehand would simply be inefficient. And secondly, pulp rots. As I said before, the dryer is our core element, and it functions much like any other dryer. Side-mounted fans blow cold, fresh air into the dryer, and after the moisture is absorbed by the hot air, it is blown out through the exhaust system again. The energy we are talking about is roughly the equivalent of providing heat to 50,000 homes for a whole year. So that's a huge amount of energy to think about. Our goal is, and always has been, to make the best use of the energy available and to recover as much of it as possible.
So as Sebastian told you, all of our concepts started right at the exhaust stream. Here you can see a visualization of the exhaust stream leaving the dryer. The reason it has not been utilized right now is that its temperature is too low for most industrial processes. That's where we looked for an idea. We came up with the idea of using a heat pump. A heat pump works in such a way that it raises its temperature level from a low level to a high level, so that the energy then can be reused for other processes. The first application we looked at was steam generation. And while there's always a need for steam in a typical pulp mill, the reason there's always a need for steam in a pulp mill, the added electricity was quite high. So that's why we looked in another application, internal water reheating. There, the heat to electricity ratio was twice as high as for the steam generation. So that's what we went with. In this animation, you can see the exhaust stream leaving the dryer, entering the first two heat exchangers, which are part of the Andritz system. Now, lastly, the stream enters a third heat exchanger, which is then part of the heat pump system. The heat pump then distributes the energy to all the heat sinks within the plant that need energy. Now, let's talk about our achievements. In terms of performance, we were able to regain an additional 32% of heat. That's the same amount as needed to heat 15,000 homes for an entire year. Looking at the environmental data, our system is able to prevent another 35% of CO2 equivalent emissions. That's the same amount as emitted by 4,600 average Europeans. Lastly, we evaluated the business case. And even with a high initial investment, the payback period is only around 4 years. It is our hope that our system will show you that energy recovery is not only good for the environment, but good for the business as well. Choose sustainability, shape the future. Thank you.
Well, that was an impressive start. Thank you to the A team for making a greener production process in future. Talking about sustainability, we all remember the times we had this pandemic going on and nobody was able to travel, or we can't do business travel. Well, that was good for the planet, but it was a pity if you need urgent communications, maybe from a plant which is located in another continent. But that's where our next team has a solution for it, and where XR technologies are going to help. Please welcome on stage Liz Bora and Zoe from Team Expert.
Thank you, Marion, for the lovely introduction. Hi, everyone. My name is Zoe, and this is my colleague, Liz Bora. Hello. We want to start off by asking a question. Who here has ever heard of extended reality before? All right, I see a few hands. Well, if you think you haven't, I bet you have heard of head-up displays or Pokemon Go before. These are both examples of extended reality. But, Liz Bora, what actually is extended reality?
Extended reality, or XR for short, is a technology intended to extend the physical world with digital content. But how can technologies like this be used in a meaningful way in the global product development where departments and sites are located all over the world? Well, this is exactly what Fronius has asked us to look into. So now, for a moment, we invite you to imagine a situation probably familiar to a lot of people sitting here today. There are two colleagues, Gerald, located in the US, and Matthias in Austria. They want to collaborate and review a 3D model together. To meet, they can either travel, costing time and money, or they could use an online meeting platform, increasing the potential for miscommunication and reduced communication quality. After all, we all know that it's not uncommon to encounter people who prefer not to turn on their cameras during online meetings, right? What do you think, Zoe?
Well, either way would worse. But nowadays, through technological advancements, we can do better than that. And this is why for Fronius, we see a big potential in using XR technology to improve remote collaboration and visualization of 3D content. But this is easier said than done. Probably everyone in this room knows that embracing change can be difficult. New technologies can be hard and intimidating to get used to. So to help with this, we have come up with the Fronius trolley, or as we like to call it, the Frolly, to make the onboarding experience of the employees for our use cases as easy as possible. The Frolly is a small trolley that provides a safe storing space for all components needed to make an XR system work. Inside, we have space for a laptop, XR glasses, a Wi-Fi modem, as well as the energy management between all of these components. But instead of explaining our vision to you, we're simply going to show you.
Oh, wow. Remember Gerald from the previous example? He is here now, so let's improve his collaboration experience. He is now in his office in the US and has an XR meeting in VR with Matthias in Austria. To get the meeting started, he opens the Froley and takes out the laptop and the XR glasses. For the meeting, he has already prepared a 3D model that he wants to show in the virtual environment. All that he needs to do is open the collaboration software, upload the 3D model, put on the glasses, and join the meeting. Now, Gerald and Matthias are in a virtual room and can both see and interact with the 3D model. They can perform actions such as inspect layers, vary scale, highlight, or annotate. When they are done, they can either export the object or just leave the room as it is for the next XR meeting. All that is left to do is put all components back to the Froley and close it.
So, to conclude, with the Froley, we intend to provide a compact package that creates a hassle-free environment for a fully equipped XR system. It can be easily integrated into any office space as well as be distributed to sites all over the world. Like this, we aim to take remote collaboration and visualization to the next level and bring remote work one step closer to reality. Our team... Thank you. Our team, Matthias, Lisbora, and Gerald, welcome you to visit our stand in the back to have a closer look at the Froley later.
Thank you.
Thank you.
Thank you, Team Expert. Looks like you're going to change the way we communicate on our workplaces in future. Thank you. Well, speaking of changing habits, fuel cells are becoming more and more part of the mobility solution. But building and testing these fuel cells requires a lot of knowledge and technical skills. The next team designed a measurement system that can be used universally and provide a maximum amount of information. Please welcome on stage Lovisa and Ivan from Team Sonic.
Hi everyone, and welcome to our final presentation. I hope you have enjoyed the Gala session right after introducing our team. We are Team Sonic, and we have been working together with AVL. My name is Luisa, and this is Ivan.
Hello.
And behind us, you see the rest of our engineering team. So if you have any questions regarding our project, this is who you should talk to. Our task has been to develop an ultrasonic flow meter with better flow measurement accuracy than the ones that exist on the market today. So, before coming back to the Formula 1 car, I will tell you what an ultrasonic flow meter is. An ultrasonic flow meter is a device that measures the velocity of a medium, for example, fuel, with help of ultrasonic waves. Ultrasonic transducers send signals back and forth in a pipe, and behind us you see a simplified animation of what this looks like. So what we see here is that the signal going with the flow is faster than the signal traveling against the flow. And with this difference, you can calculate the flow rate of the medium. So finally coming back to the Formula 1 car. Every Formula 1 car is equipped with not one, but 2 ultrasonic flow meters due to the strict regulations of fuel intake. And as limits are pushed further and further, then better measurement systems such as our ultrasonic flow meter is needed. Compared to other flow meters, the ultrasonic flow meter has reliability, is the smallest in size, and has the highest accuracy, as it do not interact with the medium or have any moving parts. However, it is also the most complex flow meter, which made our task hard and challenging, but also quite fun. And with this said, I will give the word to my colleague Ivan, who will tell you more about our solution.
Thank you. And now, I would like to present to you the Sonic Duo. The most important element of this new device is the incorporation of a double measurement path. Current top market devices can achieve a measurement accuracy of about 0.1%. With our new element, we can assure a measurement that can be upwards of 40% more precise and also have a much better reliability. To incorporate this new feature without significantly increasing the size of our device, a quite complex arrangement of pipes needed to be created. Initially, there were some concerns that this bend shape would influence the flow too much and have a negative impact on the accuracy. However, after detailed computer simulations, the team concluded that the flow was just as stable as simpler devices, which gave us a green light to create a physical prototype. For physical prototyping, we incorporated what we call relative benchmarking. As we are comparing ourselves to state-of-the-art devices, a direct comparison would be quite difficult. So initially, we tried to create a generic version of a market-available device so that the quality is equalized and we have a better comparison standard. After that, armed with a few microcontrollers and transducers, we started 3D printing prototypes, assembling and testing. We created one batch of prototypes after the other. Fortunately, due to some component constraints, our final working prototype slightly differs from our final design. However, we've made sure that all the achieved results are transferable. And now, coming back to the Sonic Duo, the smallest double measurement ultrasonic flow meter. After the testing, the team has concluded that if our device was professionally built in an industrial environment, it would achieve unmatched precision and quality and reliability in a compact package, which would make it ideal for use not only in race cars, but also commercial vehicles and testbeds. With this, I would like to thank you for your attention and end our presentation. That's fine.
Thank you, Team Sonic, for coming up and inventing the Sonic Duo. Well, measurement systems, a great thing. But our next team has dealt with communication, especially with communicating energy and data in harsh environments through metal. Well, that's a thing which is not possible today and kind of sounds like a future concept, right? But no worries, we got you covered. We even have some time travel here today. And if my clock is ticking like probably, and I think that it does, so right about now, there must become 2 persons on stage from Team Wavelinks who are going to tell us all about ADL. So welcome on stage, Sora and Simon from Team Wavelinks.
that was a bumpy ride. But we made it. We made it. We are back from the future, just in time for the Innovation Gala. I can't wait to tell all of you about what ADL can do.
Like Marty McFly said, I guess you guys aren't ready for this yet, but your kids are going to love it.
My name is Zora.
And I'm Simon.
And all these beautiful people on the screen are part of our team, Wavelinks.
For the past 6 months, we've been exploring the wonders of acoustic data link, which is through metal data and energy transfer using ultrasonic waves.
I know what you're thinking. What is ADL? To be honest, we were asking ourselves the same thing when we first started doing this project. But believe us, it is much easier to understand than it seems. We'll show you how it works on one of our first use cases.
There is currently no way to monitor what happens inside car batteries during transportation or storage. Because of their components, they can cause fires. Data cannot be transferred using NFC, RFID, or Wi-Fi through metal enclosures. And this is where ADL comes into play. First, the piezo elements are placed on both sides of a metal wall. On the inside, there is an ADL link with a connected sensor. On the outside, the reader is placed on top of the piezo. Energy flows in and powers up the sensor, while data flows in both directions as the piezos vibrate on a metal wall. Once everything is assembled, we can get live data as well as easy access to car battery conditions at any time.
The implementation of ADL can bring numerous benefits. Its flexibility allows for customization, making it applicable across various fields of industry, such as pharmaceutical, central heating, automotive, or food, just to name a few. In our search for applications, we focused on those that fit our conditions, closed metal chambers with harsh environments. That is why we decided to build our pressure chamber prototypes.
The biggest challenge for us was solving an alignment problem. So we made alignment tools ourselves. In addition, electronic components were covered to protect them in different environments. And all of this was then used in our final prototype.
Although this technology is still in the early stages of development, it has a wide range of applications in the future. With ADL, the future begins now.
Thank you, Simon and Sora, and for giving us insights into this acoustic data link technology. And have a safe trip in your DeLorean. Well, today we've heard a lot about sustainability, virtual reality, measurement systems, and we even had 2 time travelers on stage. Sounds like your wildest dreams, as a famous singer once said. And now I'd like to introduce to you the last team of this evening. Trucks are an essential part of our daily lives. But have you ever thought about the unloading and loading of the tailgate systems of these trucks and how to improve that safety? Sorry. Well, Claudius and Konstantin and the team Taylor Swift has done so.
Hi everyone. Does it work already? Nice. Thank you, Marion, for this nice introduction, and a warm welcome also from us. My name is Claudius, and I'm on stage together with Konstantin. Hello. We are part of Team Palfinger, aka Tailgate Smart Weightlift, or just simply Taylor Swift. Our name describes us and our project pretty well. So, first of all, and I think it's pretty obvious, yes, we are Taylor Swift fans. And secondly, our challenge was to find a smart way to increase tail lift safety. But let's go step by step. I'm pretty sure you have seen the thing this man is standing on before. It's called tail lift, and it's used to load and unload trucks. The platform can either be lowered or lifted, as well as tilted using a hydraulic system, and through which it is mounted to the back of the truck. Actually, a tail lift is a very critical part in the logistics chain. Just think about it. Everything you buy or consume at least once has been transported with by truck and therefore lifted with a tail lift. So what if the tail lift then breaks? Then the logistic chain is interrupted and the shifting will be delayed. Okay, but what needs to be considered during the loading and unloading process to ensure availability and therefore reduce the risk of failure? The answer is correct loading of the platform. For example, if a tail lift has a maximum capability of 2 tons, operators are only allowed to place these 2 tons in the green marked area. The reason for this are the mechanical properties of a tail lift. So when placing something outside this green marked area, operators need to decrease the weight of the load. And that leads us to our challenge. Untrained operators often do not know how to correctly handle a tail lift and therefore accidentally overload the system. So even though a tail lift is designed safely, overloading the system by just a little bit all the time reduces the lifetime, leads to unexpected maintenance, and therefore we have a lower availability. But how could an operator possibly know how much weight is currently placed on the platform and where to place it correctly?
And that's exactly where we come in. Our goal was to design a system that ensures the correct loading of the platform. So to find this out, we had to identify the weight and the position of the load on the platform. With this information, we could evaluate if the load is placed correctly on the platform. So there are numerous ways to find out the weight on the platform, but we decided to measure the pressure changes inside of the hydraulic system when you place something on the platform. So the detection of the position turned out to be a little bit trickier. However, we solved this problem by using the bending properties of the platform. When you place something on a platform, the platform bends until the specific location where the items are placed. So after that specific location, no further bending occurs. And this brings us to our final prototype. Or as we like to call it, the don't shake it off. The small things you can see on here are our bending sensors. And they are pretty easy to integrate to the tail lift. You can see our prototype here, and maybe you have already seen it downstairs. With our prototype, we can detect where the load is placed and how much weight is currently on the platform. So these are exactly the informations we need to detect if the loading was correct or not. So as you can see, our system is essential to get further insight about the loading processes of the customers and the use of Palfinger's product in general. By using these additional informations, we can predict when to maintain a tail lift, and therefore we can improve the availability and the lifetime of the tail lift itself. We see a high potential behind our product and are very excited to see how the further development will go, and we want to ensure that you get your products in time.
Thank you, Team Taylor Swift, for making our trucks even safer, as they are already. And that was it. That was our last team of tonight, of our 5 student teams. And what should I say? I could not be more proud of them. But now, we want to know what you thought about our students and their results and their projects. This year, we will give them with an PI award for the best overall team. The teams got already some ratings. They got points. They collected points basically over the year. And the last part of the rating, which is 33.30.3%, is your vote. So please scan the provided. Oh yeah, before I give you the QR code for voting, I want to present to you in a nutshell what the 5 teams did, that you have them already and fresh in your mind. Our A team, Team Andritz, started off with an innovative solution for making pulp production more sustainable. Team Expert, with the company partner Fronius, worked on XR experiences and invented the Frolli. Team Sonic, with our company partner AVL, worked on a measurement system and came up with the Sonic Duo. Team Wavelengths, with our company partner TDK, worked on acoustic data link solutions for transferring data and energy through metal in harsh environments. And our last team, Team Taylor Swift, with the company partner Palfinger, worked on the safety of our tailgates. And now, please scan the provider QR code and vote for the teams. Well, the QR codes will apply on the right and the left side of the stage. And while you are voting, I want to talk to our students, maybe future students, because now it's your turn. You want to take part of one of our innovation projects. It could be the Makerthon, it could be SpInnovation, or you want to be one of our product innovation teams. Well, we got you covered. Our next patches start in autumn, and even though you think now, I have to have ideas, I have to have special skills, no worries. We start basically from zero, and all you have to bring is you and yourself as the hero. So we start with the challenge we give you, and then we guide you through the process of ideation, prototyping, and testing. And if you're interested in, just let me know or visit our website, iim.tugraz.at, because the applications for next year are open now. And the voting process is still going on, and therefore, now I'd like to introduce again Professor Ramsauer to the stage, who will give you some insights in how you can become a company partner of our institute.
Thank you, Marion. And please give me a sign when you are finished with the votes, because I don't want to hold you up too long. For those who are here from companies, we do have a format how to cooperate with us. And I want to show you, beside the product innovation and the Makerthon, also some other formats, what you offer. As a company, you can basically rent our space for a few days or for a week exclusively for your purpose. We call that innovation sprint. Development teams from industry use the Schumpeter laboratory exclusively. It's also important so we have an NDA for you, so you don't have to worry about that. You can also get a membership for your employees. Maybe you have employees who just love to work with 3D printers, with laser cutters and other machines. We rent this location out as an event location. This location has been used during the pandemic, by the way, quite often. I remember companies like, what's the company called, the famous one with the ear device, Neurot. Oh, I should know that. Neurot was using the space for 2 days, and it looked like a TV station here to have online meetings and knowledge transfer to their dealers and so forth. For example, we had here ÖBB and many other companies. You can order, you can use our machinery, or you can ask for prototyping, and we do prototyping for you in our workshop. We focus on value engineering. Value engineering also design to value, to look at your product, and we have a look with our methods how to have the same functions with lower costs, or to create new functions with the same cost for your product. And we also provide innovation trainings, mainly Hans Schnöll. Actually, where is Hans Schnöll? I think the audience don't know you. Could you come on stage just very quickly? He is the head of the innovation group, and you have...
I'm responsible for the voting, and as we know, that's a quite important...
Okay, thank you very quickly. Voting is very important in these days. So he does all the most of the innovation trainings, just that you know who I'm talking about. So be careful with the votes. Of course, you can do master thesis. You can use our seminar room. We can offer an experton. This is our 3 university assistants from 3 different institutes who collaborate and offer their services. We have industrial management trainings. So Maria Huller is here, and also Matthias Wolf, who do the trainings. Maria, maybe you come on stage also quickly, and Matthias, who just did trainings for ÖBB in Vienna and for Andritz on the 1st of June, right? So these are our trainers for industrial management. Matthias Wolf is a postdoc. Maria Huller finishes the dissertation in a few weeks. So big hand. Matthias Wolf also leads few projects on energy efficiency and CO2 balance. We just started a project with the company Paya on that, for example. Lean production, agility, of course, that's a backbone in industrial management. Digitalization and Industry 4.0 is, of course, we did do that for many years. And factory planning and simulation is something what has been asked many times. I heard today that we planned 125,000 square meter of factory space in Austria. And I would say roughly half of them was really built in Austrian companies. So we can simulate whole factories. It's a ton of work, but if you include students, you know, they work very hard for many, many months. So you get a very good model of your factory, and we can simulate different scenarios. This is roughly the program we can offer for you if you would like to talk to us. So I'm just asking quickly, is there a vote? Just test if the Excel, it didn't, okay, good.
All good.
And we do have a winner.
We have a winner.
Okay.
So, I know their team name is already related to a star, but today they are also the stars. So, the PI winner of this year is Team Palfinger, Team Taylor Swift. Please come to stage.
Gratulation. Congratulations. Gratulation. Gratulation. Congratulations.
So we have Claudius, Oliver, Konstantin, Priti, and Fuad. Machen wir jetzt mit Ihnen ein Foto? Quick picture. Let's take a quick picture together, and then we will proceed. Thank you.
I go to the other side.
Closer together.
Super.
Hans.
Hans. Oh, it's your team.
He was the coach of this team, so. But all fair. No, literally, I prepared this. Good. Then it's time to say thank you.
Yeah, it's time to say thank you. We're at the end of this talk. I want to thank the supporters and the mentors of these teams. It's Itztok Balcic from Maribor University, Hugo Karev from TDK, Stefan Lipic, Maria Mittermeier from OMV, Stefan Hauswiesner, Michael Müller, Bernhard Kiener, Matthias Friesnig, Patrick Stelzer, and Andrea Huber. And I would like to ask Andrea Huber to come on stage, please, because Andrea Huber is an opera singer, by the way.
Don't worry. Thank you.
Andrea, it's not easy when you are a professor at the University of Technology with lots of geeks around to have to present something. So the performance, what you just saw, is a lot because of you trained them quite a bit. Well, so we have
very talented.
so we have a present for you. Please stay here.
Oh yeah. Oh, thank you. Thank you so
For
much.
you and some flowers.
Oh, awesome.
Yeah,
What a pleasure.
please stay here, Andrea, because I would like also to thank the IIM team, my staff, Atakan Kedenci, and please come all on stage. Atakan Kedenci and the A team, Patrick Herstetter and Team Expert, Andreas Kohlweis and Team Sonic, Hans Schnell and Team Taylor Swift, Team Wavelengths, Matthias Stangl, Felix Wögerbauer, the guys who are in the prototyping lab, and then my administrative team, Ulrike Dörn, Teresa Huber, Daniela Neukam, Jasmine Sangrando, and very important also Philipp Ruschal, Philipp Drescher, Marvin Ranschel, Martina Miskovic, Andrea Djerdovic, Dorcas Okoi, and Marion Unek, our student guys. But I want to say a special thank to Dorcas, and please come to me, Dorcas. Yeah, here she is. Here she is. And especially Marion Unek. Marion Unek, she had tons of work the last half a year, and that was her success today, I would say, for all the teamwork. So, danke. Marion, danke. Please come all on stage. Come here.
We do a group picture, so everybody
Yeah.
who was mentioned on stage now. And could we change the background?
Bitte, come here. Patrick. Don't Please, come. Vieni, come. Ich habe noch ein paar Blumen hier. Die mache ich jetzt gleich. Okay.
Non voglio perdere mai neanche un attimo. Diventeranno facili i baci dell'estate. Passeremo insieme 100 ore innamorate, ma poi verrà il giorno che partirò. Alla stazione verrai, la mano tu agiti. Ciao, ciao, io sto per piangere. Ciao, ciao, il treno va e grido. Ciao, ciao, non ti scordare di me. Ciao, ciao. E sulla spiaggia limpida non è cambiato niente. Sotto il sole caldo io ti cerco.
Okay, thank you very much for coming, especially the company sponsors. Now it's time for food and to connect and talk to each other. Please enjoy your time.
Ciao.